Hello everyone, so welcome to the series of Border Gateway Protocol. And dear all, I already have uploaded the series of OSPF classes as well as the EIGRP and Routing Information Protocol. Okay, if you want the reference of any of these, you can cross check the playlist for the same. Now let's talk about the Border Gateway Protocol. Well, it is a routing protocol, a dynamic routing protocol. Dynamic routing protocol. And let me tell you, if you are new to the BGP protocol, so please get a brief overview about the OSPF, EIGRP, and routing information protocol before going to study about the BGP. You must have a good knowledge of the other interior gateway protocol before studying about the BGP. So I will recommend you to study all of these protocols and routing, static default routing before going to discuss about this BGP protocol. Okay. Dear, what is the BGP protocol? It is a routing protocol that is used to exchange the routing and reachability information in between autonomous system on the internet. Let us assume that this is my ISP1, okay, connected to the ISP2, sharing the data to the ISP2. So all the ISPs or the organization has a specific autonomous system number, AS number. So this protocol BGP is basically used to share the data, information of routing and reachability in between different autonomous system number, because all the ISP has their specific autonomous system number. And because of this protocol, BGP protocol, the internet is working. The global routing table can be handled by this BGP protocol only. Okay. We have two types of BGP protocol. eBGP protocol that is used between the two different autonomous system number, like AS 4000 to AS 4001. So it is used to share the information, or it is used to do the routing information, exchange the routing information between the different AS number. If I talk about the iBGP protocol, it is used to share the routing information in between the same autonomous system number. If I talk about the EGP protocol in comparison to IGP protocol, let's see what are the difference in between these two. According to the definition of IGP protocol, IGP protocols are used within the same autonomous system number, like AS400 to AS400. The EGP protocol is used between the different autonomous system number, like AS4001 to AS4005. Let's talk about the scope. It is used in the internal network, basically for the enterprise ISPs, AS for internal networks. But the EGP protocol is used between the ISPs, different ISPs, or different organizations or enterprises, because sometimes the enterprise can also take the specific autonomous system number. What are the interior gateway protocols? These are OSPF, EIGRP, RIP, and IS. But the BGP protocol is the only single protocol for the exterior gateway protocol used for the global routing. Let's talk about the use of IGP. It can be used for the routing within a single organization, but EGP can be used for the routing over the internet in between the different organization or different ISPs or different enterprises. Okay, scalability. It is fully controlled by one organization, but EGP protocol, the BGP protocol, can be shared between the multiple organizations, multiple nations, multiple states, or multiple ISPs. If I talk about the speed, interior gateway protocols are really having the faster convergence. These are the faster protocol. The EGP protocol can be slower due to its stability as well as the path selection procedure. It is somehow a slower protocol. Let's talk about the path selection. The path selection basically done by the metric values like cost and bandwidth, but in case of EGP protocol or the BGP protocol, that is policy based routing, and the path will be selected by the help of attributes. So how many are there? There are 11 attributes on the behalf of which path will be selected. Later on, we have a specific video for the EGP best path selection. Okay. Let's talk about the administrative control. A single organization can control the full IGP protocol, but in case of EGP, the connection will be shared in between the multiple organization. The authority can be taken by the multiple organization at the same time. Now let's talk about the autonomous system number. As I already told you that it is the collection of IP networks or router under the control of a single organization or ISP or the enterprise. It is basically the identity of an ISP or an organization for the global routing. It is commonly routing policy to the internet. Okay. Let us talk about the AS. It is just like a mini internet within a company or ISP, university or a government agency. It could be internet service provider, a data center, even the large enterprise also uses the autonomous system number to distinct over the internet for the full control. What is the autonomous system number? It is a unique number assigned to each autonomous system used to identify over the internet. That is means every single organization is provided by a specific AS number that is become the identity over the internet. Let us assume Airtel. This is our Spectra or any organization. This is our Exitel. This is GeoFiber. So all the ISPs are provided by a specific autonomous system number like 65001, 65002, 65003, and 65004. These are the identity over the internet. So according to the Spectra, Airtel can be recognized by the 65001 ISP AS number. So BGP uses AS number to track the path. A route has taken across the internet via AS path attributes. So basically, BGP protocol uses the AS number to track the path or a route taken across the internet. AS numbers allow other networks to know to recognize a specific organization using the routing policies. Okay, why AS number matters in the BGP? To avoid the loops within the AS path. When a route passes through multiple networks, each network's ASN is added to the path. That is means if any data is shared in between the different AS numbers like AS200, AS300, AS400, so all the AS information will be added with the data like 100, 200, AS300 and AS400. When the data will be forwarded from 1 to 200, it will add the information 100 plus 200, then 100 plus 200, 100, 200 and 300, and this information will be passed over here. Then when the same information will be forwarded like 100, 200, 300 and 400, it will observe that I already having the 100 AS number, and 100 AS number is repeated to me, so that is why this loop, this path cannot be selected within the network. So this path will be rejected by the AS 100, because if this path will be selected, then there will be a loop formation. It helps in routing decision enforcing policies. Basically, the BGP protocol is used to enforce the policy based routing protocol. So we have two types of autonomous system number, public AS number and private AS number. If I talk about the public AS number range, that is 1223455. For the private range, this is 13107224249 and so on. It is provided by the same organization, IANA, that provide the IP addresses. Okay, so IANA provide the AS number to the RIRs. Okay, that is continental wise organization handling all that. If I talk about the private AS number has a range of 64512 to 65534 and 4200000000 to 4294 and so on to 32 bits. It is used for the internal networks just as the mini internet within an organization. Now let's talk about the IANA. So in IP addressing, I already explained you what is IANA in CCNA. Okay, it is an organization that is used to assign the global numbers to the internet, and it is the key element of the internet because it provides IP addresses to the ISPs and users. Also, it controls the AS numbers. So IANA is responsible to provide or allocate the AS number to the multiple regions of internet of RIRs, regional internet registers, RIRs. So IANA used to provide the range of AS number to the RIRs. Then RIRs are the non-profit corporations established for the administration and registration for IP addresses allocation as for the geographical locations. That is means for the specific location of geography or specific states country wise, the RIRs are going to provide the IP addresses, spaces and the AS number. INA is doing the four function like IP address allocation, AS number allocation, DNS root zone management and protocol assignment. Let's talk about the regional internet registers. So RIR are area networks for the North America, US, Canada. RIP, ENCC for the Europe, Middle East, Germany or UAE. AP, NIC for the Asia Pacific. LACNIC for the Latin America and AFRINIC for the Africa. Now, this is how it looks like. Now let's talk about the BGP protocol. As I told you that BGP protocol is exchanging the routing information in between the different autonomous system numbers. So BGP is a protocol that is used to exchange the routing information in between the different AS number over the internet. It is a path vector protocol having the TCP IP port number 179. It is defined by the RFC 4271. Now, what is the main functions of BGP? Without BGP, internet cannot able to function, and it is also responsible for the best path between the networks across the globe. That is means for the global routing table, the internet find the best path on the behalf of BGP because this is the only protocol that runs over the internet. Well, it provides the control routing decision to the ISPs, enterprises, data center, and cloud providers. It prevents the routing loop using the AS path. Well, it also prevents the loop formation within the multiple AS numbers. It enables the policy-based routing, not just for the matrices. Let's talk about the BGP protocol. So BGP is only protocol that is providing the inter-domain routing between the different AS. It is used between different ISPs and also can be used for the ISP enterprises. So BGP can behave with the different protocols. It was built for the reliability, scalability, and full control over the speed. BGP is a path vector protocol in which routers are tracked in terms of which autonomous system they pass through. So this is how the BGP protocol works. So this is the autonomous system number 100 and this is AS 200. Here we can see that multiple routers are communicating to each other. So internally the router will be communicate with the help of IGP protocol and externally the EGP protocol we use to forward the data in between the different autonomous system numbers. Let's talk about the BGP. Which one is the best path? Here, if I talk about the path number one, there are three AS number in path number one. Let us assume this is our source and this is our destination. In between source and destination, how many AS path number are there? One, two, three. So three AS number are there in between the this path. And let's talk about path number 2. Path number 2 having 1, 2, 3, 4. So which path having the least number of AS numbers will be selected as the best path? Here we can see this path is having the least number of AS numbers, so that is means path 1 is the best path for the same. That is explained over here. Now, why need the BGP protocol? The reason is that to connect over the internet. So if you want to communicate to the internet without BGP, it's not possible. For the policy based routing PBR, to take the control, to take the full control over the traffic, and to create the routing decision and traffic engineering, we need the policy based routing. In the same path, in the same way, we need the BGP protocol over here. The BGP protocol is needed for the stability and control for the large network, because in global routing table it can be possible that there can be millions of data that can only be managed by the BGP protocol because it is designed for the stable and conservative purpose. Let's talk about the routing decision. So a global routing decision can have a million number of routes, so that cannot be handled by this IGP protocol. Even the router that are handling the BGP protocol are high-end routers. Like EIGRP, OSPF can work within the same AS number. BGP can work within in between the thousands of AS numbers. If I talk about the real-world cases, when we can use the BGP protocols, when we are connecting with the multiple ISPs, we can use the BGP protocol. If you are working especially for the ISPs, you need the BGP protocol. For the large data centers, a large organization with multiple branches also needed to have the separate AS number to share the data internally. We have to use the iBGP protocol, because iBGP protocol also handles the routing design with the help of policy based routing. So in case of large organization, we can use that. In case of cloud connectivity, AWS, Azure, or GCP, we also need the BGP protocol, because over the VPN or direct connect or express route, BGP is the best protocol. Well, in case of MPLS VPN, if we want to initiate the MPLS VPN for the service provider network, we also need the BGP protocol. Routing decision can also be taken by that, like route distinguisher RDN, route targets RT value can only be decided by the BGP protocol. If I talk about CDN network like Cloudflare, Akamai, all of these can be all of their server announcing their contents from the multiple location. In that also we need the BGP protocol for the CDNs. Okay. Now let's talk about the traffic engineering and route optimization. So to lower the congestion and to take the full control, we need the BGP protocol. And the attribute like local preference, MED, and communities can also be used in that case. Okay. Let's talk about the peering at internet exchange point. We also need the BGP protocol to reduce the latency and save transit across over here. What are the characteristics of BGP, dear? Interdomain AS routing protocol. Well, it is used to do the routing in between the different AS number. It is a path vector protocol. It is not the distance vector protocol like other protocol or link state, but it is a path vector protocol that depends over the attributes, path attributes. Let's talk about the other characteristics. So it prevents the loop via AS path. It does the policy based routing taking the following attributes. So later on we have a video over the attribute also. Okay. Well, BGP supports both EGP and iBGP. In eBGP, it is used to communicate with different AS number. IGP used to communicate in same AS number. It is having the slow convergence because of large number of routes inside that manual configuration. There, all the neighborship can be created with manual neighborship. We don't have the uh, automatic neighborship like the OSPF or OSPF or EIGRP. It is a TCP based protocol basically. It is highly scalable. Millions of routes can be handled by this protocol. It supports the route filtering and manipulation with the help of prefix list, route map, and AS filter. We will have a separate video for that also. It is a classless routing protocol. It uses the attributes for decision making. There are 11 attributes which are used for the routing decisions. If I talk about the BGP table, so BGP also have its separate routing table other than its routing table. So there are two tables over there in case of BGP protocol, BGP table as well as the routing table. It uses the route attribute for the decision making. Obviously, the BGP protocol is policy based routing protocol. It generally uses the route attributes for the decision making, and BGP timers also there. If we compare with the other IGP protocol, so hello timer in EIGRP is of 5 seconds. In OSPF, it is only of 10 seconds. But in case of BGP, it's 60 seconds overall. So that is all about the basics of EIGRP protocol. And now we are going to deeply discuss about this. Have a nice day, everyone.